What's up, everyone? So we're in the middle of the fastest acceleration in software development that the industry has ever seen. In the past months, we've seen incredible progress. We've seen OpenAI release GPT 5.4 Thinking. We've seen Opus 4.6 come out of Anthropic. I don't know if you all have played with them, but these are seriously impressive models. And the potential for this, long horizon autonomous work where they go off and create things on your behalf is seriously mind-blowing. If you haven't played with them, you ought to. And there's clearly even better models coming. We're seeing people create incredibly impressive things this way, all with natural language. People are calling this vibe coding. Pretty much everyone has heard of it at this point. It's kind of a fun term. It sounds liberating. You put in your description and poof, you have software. It's a little more complicated than that. But that's basically how it works. And as fun as that sounds, it's a serious tool, right? In the hands of a senior developer, this can produce incredible outcomes and efficiency. But here's the thing, and this is what I really want to talk about today. When it comes to the enterprise, this AI code generation presents all kinds of problems. If we're not careful about how we harness this power, it leads to things that are worse than today's common complaint of technical debt. The term that people are using to describe the problem that is presented by AI coding is cognitive debt. And also, I'm hearing it called epistemic debt sometimes. But cognitive debt is what happens when your team doesn't fully understand the code that it produces. It's basically knowledge debt, AI supercharges this phenomenon. In the past, it was really only a thing that happened when, projects changed hands. You had a new team managing an old code base that they didn't understand. Because when a developer builds code by hand, they understand it, right? There is a mental model that is built through the process of writing that code inherently. But when they're using AI to generate that code in seconds, the software works great, potentially, right? But that mental model is not getting built, or at least not to the same extent. There is an unknown here. The point is that it's going to vary, and we're not even going to know, right? Sometimes your developers understand the code, sometimes they won't. Sometimes they'll say they do, but they don't. Sometimes they think they do, but they actually don't. The code can be the best code ever. It can be written with incredible efficiency. That doesn't matter if no human understands it. So fundamentally, with vibe coding, you can count on the fact that your developers won't be absorbing the same level of understanding about what they're producing. And there is absolutely research out there quantifying this. So we've had this problem, every time a developer that's knowledgeable leaves an organization, but that's an exception. And this would be the rule. If we're using vibe coding, this is a consistent problem. The volume of code that this would apply to is substantial. So, take that problem and scale it across the enterprise, and you have a serious governance issue on your hands, as well as a security problem. And what I think people aren't even necessarily considering is that as these large language models that are underlying all of this gets better, it doesn't make the problem better. It makes it worse. The more capable these agentic coding models become, the more tempting it is to just trust them. The more code they build without human intervention, the better it looks out of the gate, and the harder it's going to be for developers to force themselves to walk through that code and really understand it at a level that is functional for the organization. And here's the thing, right? We're still far from a level of sophistication with vibe coding where we can simply trust the outputs that it gives us. It will be hard to know when we actually get to that point too. Because the gap between an AI that's making mistakes 2% of the time and one that makes mistakes 0% of the time, that's like an ocean, right? That is a huge difference. And to pile onto this a little bit more, when we're building enterprise software, the functional requirements aren't the whole story, right? Your screens, your workflows, your business logic, these things are obviously important, but beneath the surface is a massive body of non-functional requirements that determine whether or not an app is ready for production. We're talking about security and compliance, scalability, auditability and logging, safe data connectivity, things like backwards compatibility. These are all things that AI coding is going to have trouble tackling because it does not have the knowledge base to do so. It's great for those functional pieces, but by default, it does nothing for the rest. So you'd better have a very skilled and very attentive developer making sure those things are properly addressed and implemented. Because, the point is that it's really easy to make things that give the impression of being production ready when they really are anything but production ready. Looks can be deceiving. No one wants to face the embarrassment of getting burned by one of these situations. So what do we do about this? I think that's what everyone wants to know, and the answer obviously isn't just to stop using AI. This is real efficiency and power. That is undeniable. I think I would argue we are never going back. This is the direction that things are going. So, the answer is that AI in the enterprise needs guardrails. It needs structure. And this is where Appian occupies a really interesting position, because we've been building and refining enterprise process for 25 years. And we're building it on a platform that has a lot of these non-functional requirements baked in. That scalability, that auditability, the security, all of those non-functional requirements are part of this platform. But at the same time, we are providing tools that let you harness the speed of AI-driven development. Starting with natural language, just like vibe coding. And so in the end, what you get isn't raw code that nobody understands, but actual platform objects, inherently explainable by design, and also inherently governable, maintainable, and compliant. So I'm going to show you a bit of what we call Appian Composer. That's how we do this sort of AI-powered development in the Appian platform. But the same tension plays out with agents. If you're following OpenClaw, it's a perfect example. This is a wildly popular agent framework. If you're not familiar with it, it has the benefit of near complete autonomy, but that raw autonomy means tons of risk. For the enterprise, we need to find that middle ground again. And so that's exactly what our Agent Studio does. This is real autonomy, but with foundational guardrails. For those that are interested, I have a video on this a couple episodes back. But enough talk. I want to show you a bit of Composer. So let me show you what some of this looks like in practice. So first, what we're going to do is use this document here as requirements for Composer. These are for an employee onboarding system. You can see it as a summary of the needs, some functional requirements, workflow, and data model specs, these sorts of things. So it can handle very complex inbound documentation as requirements. So we're going to go ahead and put that into the system, log into Composer. We'll go ahead and upload that document and then click Add. Now, we could provide more context, but that document is all we need. We'll go ahead and click Generate. And so immediately it kicks into high gear, it reads through that document, analyzes requirements, and it's going to produce a plan for our review, which we'll see here in a moment. And so here's our plan. First part of it is our requirements, where it's mapped out our core user activities for the onboarding system. This is a collaborative and iterative workspace where both our business and IT folks can work together to formulate a plan. So here we have one of the individual requirements for a create new hire intake form. It has an automatically generated description. Here we can also define objects that are related if we've already created any. And so next, let's make a change with AI to iterate on the plan. We're going to ask for a performance management module. It's going to think about it for a moment, provide some feedback on what it's done. So let's see what it's added. We can actually go over to our plan and see the new section. It's added a new performance management module section. So it got the assignment, completed the goal. So next, let's take a look at some of the other proposals it's making here. Here are our personas, the different users and groups. The process is going to be the overarching workflow of the application in BPMN notation. We can see a number of logical gates, steps that are orchestrated here, and it translates this into the starting point for your process models. Next, we have screens. These are going to be our dashboards, our forms, our record summaries that it recommends. After that, it's our business rules. These are going to be pieces of important business logic that it wants to create into reusable expressions. And then finally, we have our data model, which is a comprehensive specification with all of the relationships defined. This gives us all of the appropriate record types for our application. This is a particularly useful feature because creating these can be fairly time-consuming. It's definitely one of my favorites. And next, we will generate our objects. We can see the user groups for role-based security. We have all the elements of our workflow and process models. We have our interfaces created for all of our screens. We have expression rules for all of our business logic. And then we have all record types created with relationships defined for our data fabric. Huge convenience there. And so now we're ready to review. We can click Generate to kick it off whenever we are ready. And all of the objects are going to be generated per Composer's plan. It'll take a few minutes based on complexity. We can view those results, and now we can see it looks good. And so finally, the moment of truth, we can actually go and see all the objects that it has created in Appian Designer, saving us a ton of time getting started on our build. All right, so that was Composer in action. And just to kind of take us back to where we started, the point isn't just speed with this, although we certainly are accelerating development. But what really matters is what you get in the end. It's not a pile of AI-generated code that we need to reverse engineer, but it's actually platform objects that our developers already know how to read, maintain, and extend, right? The mental model is not missing here. It's built into the medium. Same with those non-functional requirements, the security, the compliance, the scalability, that all comes with the platform, right? So speed of AI-driven development without the cognitive debt. That's our sweet spot. All right, well, that is it for me. Thank you all for watching. I appreciate you all, and I will catch you in the next one.